Hello class, I'm taking notes today. Pause the video and get the title and the essential question of the notes written down and press play when you're ready. Okay, so today we're talking about complex numbers and what they are. How can I solve a quadratic function that has a negative discriminant? What that means is a negative square root. Excuse me. Okay, complex numbers. Make sure everything that you see here gets written down in your notes. So complex numbers are what we call imaginary numbers, and they are written as I. I represents the square root of -1. Okay, so for example, I is the square root of -1. So if I square both sides, so I equals the square root of -1. But if I square both sides, I get, look, I squared, and then remember a square and a square root cancel each other out. That's how we end up with -1. Here are the two things that you need to know right here, is that first, I is simply the square root of -1, and I squared is -1. Slightly different, you need to know that. I is the square, represents the square root of -1, and I squared is -1. Complex numbers are not real numbers, but can have real number parts. Okay, and we'll talk about that in a minute. So essentially, let's get this down first. Complex numbers, make sure you pause the video, rewind as you need to. Get all this information written down. Complex numbers are written in the form of a plus bi. So your first part is your real part, like 8, for example. The second part is the imaginary part, like 4i. And this happens when the graph does not touch the x-axis. So we talked about, when we were in class, about quadratics, right? If I have a graph, you can have a quadratic that touches the x-axis twice. It has two real solutions. You can have a quadratic that touches the x-axis exactly one time. That has one real solution. Or you can have a quadratic that does not touch the x-axis at all. This would have what we call zero solutions or no solution, or what we call imaginary solutions. Here are some complex numbers, and we're going to simplify these. These are examples. You can title these examples in your notes. So the first one, the square root of -7, I can rewrite this as the square root of -1 times the square root of +7. See, I'm just breaking it apart. If I multiply those back together, I would get the square root of -7. Why do we do that? Because we know that the square root of -1, as we took notes up here earlier, the square root of -1 is I. So what we do is we say the square root of -1 right here is I. Therefore, this simplified, we say I rad 7, or I times the square root of 7. Okay, moving on to the second example, square root of -49, excuse me. What is the square root of +49? You should be thinking plus or minus 7, and you would be right. Remember, the square root of 49 is going to have two solutions, positive and -7, when you take square roots of numbers, right? So the square root of -49, I can break it down to the square root of -1. I just pull the negative out times +49. We know that the square root of -1 is I. The square root of 49 is plus or minus 7. So therefore, when I multiply those back together, I get plus or minus 7i is my solution. Last one, last example here, 8i. That's just an imaginary number squared, but we can square it. Anything squared just means times itself, so what this means is 8i times 8i. Okay, well 8 times 8 is 64, and I times I is I squared. And if you remember from earlier, I squared is simply -1. So when I run into an I squared, like here, I can just replace it with -1. So what this means is 64 times -1, which is -64. And that's what, so 8i squared ends up working out to being -64. Let's solve some of these quadratics. These are 3 examples. Make sure you write them down, show your work. First one, I'm going to do it right over here, is x squared plus 12 equals 0. Okay, I'm going to subtract 12 from both sides, and that gives me x squared equals -12. To undo a square, we square root. That cancels, and I have x is equal to, now before you probably learned, oh, Mr. Falls, you can't have square roots of negatives. True, there isn't a real solution, which is why we came up with this imaginary solution concept. So we know that the square root of -12 is just the square root of -1 times the square root of positive 12, and we know that the square root of -1 is just I, and the square root of 12, so we're going to say plus or minus I rad 12. You don't need to put that in your calculator and give me some, that's just going to give you a funky decimal, so we're going to write it in exact form, and that's our solution. We can also simplify the square root as well. In fact, we'll just do that now. So there are perfect squares inside of 12. For example, square root of 4 times the square root of 3. Square root of 4 is 2, so this is 2 rad 3. So now I have plus or minus, I still have my I, and then times 2 times square root of 3. So if I put it all together, plus or minus, I times 2 is just 2I, and then rad 3. And that's the final simplified solution. All right, write down the second one. I'll do it right here. -5x squared minus 2x minus 8 equals 0. On the previous one, we were missing a b term, right? So we could solve it by square roots, the exact way that we did. The second one, we're not missing a b term. We have an a term, a b term, and a c term, so we're going to have to solve it by factoring, completing the square, or the quadratic formula, which we've learned. This one looks like it's pretty tough. I don't think it's going to be factorable. Maybe it is, maybe it isn't, but I don't think that it is. So I'm just gonna plug this right into the quadratic formula and see what our solutions are. Our a term is -5, b term is -2, c term is -8. Our quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we're just going to plug these values in. So negative, and then b is -2, so -2 plus or minus the square root. b is -2 minus 4 times a, which is -5, times c, which is -8, all over 2 times a, which is -5. All right, so let's just be real careful with our math here. So -2 becomes +2, plus or minus. -2 squared is 4. And let's be careful with our multiplying here. So -4 times -5 is 20. And then 20 times -8 is -160. So I'm going to write -160 over, and then 2 times -5 is -10. Let's simplify the square root. So I have 2 plus or minus 4 subtract 160 is -156. All divided by -10. Okay, let's keep simplifying the square root. We can see that it's negative, so we're going to pull that out, right? So I'm going to say 2 plus or minus, so the negative comes out and it becomes I, remember? Because if I pull out square root of -1, that's just I. And then times square root of 156 divided by negative 10. So let's see if we can simplify the square root of 156. I think we can. Let's pull up a calculator here. So if I do 156 divided by 4, I'm going to get 39. So that's pretty good. So I know that the square root of 156 is the same as the square root of 39 times the square root of 4. The square root of 4 is just 2. Square root of 39, that cannot be simplified. There's no perfect squares inside of there. I know it's 13 times 3, but both of those are prime numbers. So this is 2 rad 39. So now I'm going to say 2 plus or minus. I still have my I times 2 square root 39, which is what we got over here, right? All divided by negative 10, and then we just need to clean this up a little bit. So that just becomes 2i, and then notice that all three of our terms, let me write it out, 2 plus or minus 2i rad 39 over negative 10. First term, second term, third term, they can all be divided by 2. All right, so we need to do that. So I divide them all by 2, so that gives me 1 plus or minus 2i divided by 2 is 1i, or I rad 39. And then negative 10 divided by 2 is negative 5. And that's looking pretty good. We can't really simplify that any further. That's a tough one. A lot of work to do there, but that's going to be our final solution. All right. Last one. Copy it down, please. Pause the video if you need to. And I'm going to find some blank space we can do this. So x squared 8x 12 equals 2x. So x squared plus 8x plus 12 equals 2x. Okay, we need everything to be on the same side, right? So we're going to subtract that 2x from both sides first. That gives me x squared plus 6x plus 12 equals 0. Again, this doesn't look like it's factorable. We could complete the square here or use the quadratic formula. I think we could. This is a good one for completing the square because our a term is 1 and our b term is even. So we're going to complete the square, solve it by completing the square. So we're going to subtract 12 first. So that gives me x squared plus 6x equals negative 12. Now we're going to add in, let me erase this and make some space. Okay, so I'm going to write plus blank equals negative 12 because we're going to complete the square. So you remember, to complete the square, we take the b term, we divide it by 2, and we square it. So that's going to give me 9. What I do to one side, I do to the other. This is going to give me x plus 3 squared. X plus 3 times x plus 3. If I add that together, that gives me negative 3. Now I'm going to square root both sides, and that cancels that. So that gives me x plus 3 equals, and then you can see I have the square root of a negative again, right? So square root of negative 3 is just the square root of negative 1 times the square root of positive 3, and that's just I. So this gives me plus or minus I rad 3. And then I just need to subtract 3 from both sides, and I'm good. So I have x equals negative 3 plus or minus I times the square root of 3. And that's our solution there. So you can see there's some examples for you guys where we use imaginaries to solve. Before we used to say no solution, right? Because you can't have square roots of negatives. Well, we can now. We just call them imaginaries, right? That's what the I represents. So that's good notes. Make sure you guys submit them to Google Classroom when you are finished. And I'll see you guys and talk to you soon.